Today he is conducting the session on how to approach PhD research problem. So I request sir to take over the session.
Okay, thank you, Dr. Sujata. It's my pleasure to be associated with this particular FTP program. So today I'm going to talk about something non-technical. So mostly the IIT professors are very comfortable with technical things, but I'm going to talk about something non-technical, which is basically going to be useful for most of the participants here. So I'm going to share my screen.
Yeah,
Please let me
Keshav,
know.
can you please stop the sharing? Yeah.
Let me see if you can. So is it possible to, okay? All of
Yeah,
you
it's
are able
loading.
to, yeah.
Yeah, it's loading.
Okay, right.
Yeah,
Let
it
me
is
show.
visible.
Very good, right. Okay. So as I said that basically I'm a faculty member here in Department of Mechanical Engineering, and today I'm going to talk about a general topic, okay, based on my experience as a student, my experience with the faculty member here in Department of Mechanical Engineering, and also I'm going to share some of my thought process as the associate editor of one of the journals, which is quite popular one, especially in the electronics and mechanical engineering field. Okay, so today the topic is that how do you approach a research problem, okay, during your PhD study, and what are the critical steps, right? So again, this is my personal thought. It may be not like right all the time, but this is just a thought process right now. Okay. So let me just tell you some of my journey. So I started my MTech degree here from IIT Mumbai, okay, where I spent my master's degree. Then I moved to NTU Singapore, where I did my PhD program on the MEMS area, MEMS for micro electromechanical systems. And after completing my post PhD, I went to Georgia Tech, where I worked with Professor Rao Tumala in Georgia Tech. And once I completed my postdoc, I went to Finland, where I spent almost 6 years working in the research institute. And in 2015, I moved back, I had completed this triangle and moved back to the same place where I've started my journey here. Right. Now, I was very fortunate enough to get a experience, local experience of academic in India. I have experienced the Asian culture in Singapore. I also seen that how does this academic environment is different in US, and finally the work experience in the other continent, Europe. Okay, so I'm going to talk about my experience in all these three continents and how the academic things are going to be different from each other. Okay, so far I have completed two of my students have already been graduated and others are basically going on. Okay, so always start about this particular thing about a PhD research. Now some of the participants, they already may have a PhD degree. Some of them may be trying for a PhD degree. Okay, some of you may be supervising some student during your PhD research, right? So the first thing which I like to mention here, that a PhD research is not just for a student. Okay, this journey, which is go on for 3 4 5 years depending upon the funding situation, it is not only for a graduate student, but it's also for his or her supervisor. Okay, so this is a kind of a combined journey for both supervisor and as well as for the research student. Why is that? Because a supervisor might have done a PhD on a given area, okay, right? But that person may not be aware of what's going on in other areas, right? So once you supervise a student, you also experience, you also learn new things, new knowledge in that area. Okay, so this is a learning experience for for both student as well as the his supervisor, his or her supervisor. Okay, so now a good PhD is considered to be that one where a student has experienced more knowledge at the end of the PhD. Okay, a student should have more expertise, more knowledge than his or her supervisor. Okay, that's a very critical thing, because that person, graduate student, you need to devote 4 to 5 years on a given topic, right? So PhD is basically knowing more towards the depth here. Okay, So this is basically the depth area where you need to go and find out why something is happening, why is not. Okay, and at same time you also need to learn about a little bit of other areas. Okay, so you should have a very good depth in one of the area, but at same time you should also know what is going on in the corresponding associated areas, right? So depth and width both are going to be very critical things here. Okay, so main reason is that why some you are doing PhD. Okay, because you are motivated primarily because you would like to know, you would like to enhance your knowledge. Okay, you like to add some kind of a contribution to already existing areas. Okay, now there's a very famous saying in English that there is nothing new under the sun. Okay, it means that whatever we are trying to develop it, whatever we are trying to make something, we are basically learning from nature, right? So for example, in mechanical engineering, we have something called lotus effect, right? So if you look at these leaves of lotus, right, it's a complete hydrophobic surface. Okay, and we are now learning from this thing, we are understanding how the microstructure of the lotus leaves, and we are trying to implement the same thing in the microfluidics area, right? So PhD is always about a learning new things and how you can contribute to that particular. Okay, that's a very critical thing. Okay, now before you begin your PhD, right, you have to choose a supervisor, and a good compatibility is always very important. One of the major factor here why someone PhD is very good, okay, somebody is not so good, is about the basic compatibility with your supervisor. Okay, so in one of the, this is a very famous PhD comics which is very popular with the graduate student, okay, where they had compared a marriage versus a PhD program. Okay, so average marriage in Western countries in US last for roughly about 7.5 to 10 years. Okay, but PhD goes on something about 7 years. So you will find a lot of similarity between a marriage and your PhD. So if you find a good supervisor, a supervisor who can understand, okay, you, or with whom you are basically comfortable in sharing your thought, then your PhD work is going to be enjoyable. So if you are a supervisor, okay, my request to all of you is to be as accommodative as possible, okay, so that you can learn, basically you can be comfortable, so that your students can be open while sharing their thought process. Okay, as a supervisor, okay, you have to be humble. Okay, and also, which is not very popular within India, is this thing, right? So for example, you sometimes it happens that a student's thought process are not really matching with what you are saying, right? So you have to be also be open for some kind of criticism or positive criticism from the student side as well. Okay, as a student, important thing is that you should be really open. Okay, if you have some thought process, if you are not really agreeing with what your supervisor is trying to tell you, okay, you don't have to be scared. Okay, you have to discuss with your supervisor. That is one of the things, because if you are not open, sooner or later you will have a problem, because you are not comfortable in that area. Okay, and you will have that particular issue. Okay, so it's always a good idea that whenever you have this kind of a difference in opinion, you need to sort it out with your supervisors. Okay, now if you look at things, different research cultures are going to have a different opinion. Okay, so for example, I will say that in most of the Asian universities, okay, there's a kind of a hierarchical system. Okay, it means that you have a graduate students, bachelor students are somewhat here, then you have a master's students, you have a PhD students, you have a postdocs, okay, and then you will have your faculty members, and this is most likely going to be head of department, right? So it has this kind of a pyramidal structure, which is popularly you will see in Asian universities. Okay, so supervisor is always kind of a right. It means that even though you sometimes you do not agree with your supervisor, you have to follow their advice. Okay, so Asian culture follow this particular habit. But if you have a cross-cultural supervisor, for example, in Singapore, my own supervisor was a Chinese, and I was the only Indian student in his group. Okay, so because of this cross-culture things, fortunately, he respected my ideas, I respected him, and that thing has turned out to be a very positive outcome for both me and my supervisors. Okay, so Asian universities mainly focus on the government-supported project funds. Okay, if you look at this thing, how the European research culture and how a US research culture works. Okay, so Europe is very, very liberal. Okay, so supervisor is not really something very senior, it is just kind of a senior colleague. Okay, with whom you can go out for dinner, you can have a smoke together. Okay, and both of them have this kind of a mutual respect for each other. Okay, that's one of the best thing in Europe. Okay, so if you are not agreeing with what your supervisor is saying, okay, he or she will totally open it admittedly without any kind of a ego issues. Okay, so it is perfectly all right in European universities, okay, to disagree with your supervisor. Okay, but the same thing you will not see in case of Asia or most of the Asian universities, I would say. Okay, in Europe, okay, problems are mainly well defined because the funding period is limited. Okay, so if you look at UK PhD problems, they are typically about 3 years, 3 to 3.5 years. Okay, in UK. If you look at France, it's also about the same kind of period. It means that once you join a PhD research group, okay, your PhD research is going to start from the day one itself. Okay, so problem is well defined. Okay, objectives are well known. Okay, and because the funding is going to be limited. Okay, if you compare with, for example, India, IITs will fund you for 5 years. Okay, and in the first year you have to take a lot of courses, and at the end of the first year you have to formulate a research problem, and then only your research will actually start. Okay. If I compare with US universities, okay, they follow this kind of a balanced approach because in US you'll find researchers from most of the other countries, okay, including Asia and Europe. Okay, so they follow this kind of a balanced approach. Okay, the PI or the supervisor, his mainly job is about arranging the funding or arranging the suitable facilities within the research group. Okay, they also follow this kind of a pyramidal structure where we have a postdocs, we have a PhD things. Okay, and PhD guys are free to discuss the problem with the senior postdocs and the supervisor itself. Okay, so if I can say that in US, the problems or research problems are mainly driven by the what is the industry need. Okay, so during my postdoc, I worked on a problem given by a consortium founded by the semiconductor companies like Intel. Okay, so when I joined that program, so industry has already given them that this is a problem we would like to solve. Okay, so the problem was ultimately application driven. Okay, in which you will have a close interaction with the industry people, you have close collaboration with your colleagues within the department, outside department. Okay, and during the PhD, one of the very important aspect is about the internship. So if you look at Indian PhD culture, okay, or even in European research culture, you will not find a rigorous internship thing, which is basically a very important aspect of a PhD culture in US. Okay, and because of this reason, if I may say that many of the PhD topics within India are not really going to be applicable what industry exactly wants. Okay, so this is one of the loopholes where we are trying to sort it out here. Okay, so these are some of the key difference which I have observed during my interactions in different institutions. Right. So now let's talk about the PhD, right? So PhD, as I said, that you have to develop a very solid understanding about the basic fundamentals. Okay, so you have to go in detail. You have to really go on a given area in depth. Okay, and ideally you should be at the end of your PhD, you should be known as one of the experts in that particular domain. Okay, while having also the other knowledge about the other areas. So you will have, like I said, you should have a very good depth in your area, but also a very good understanding of the other areas as well. So that is a very, very key things, because it may be very much possible that once you complete your PhD, right, when you go for a postdoctoral work or when you go for a job, you may not be working in your given areas. Okay, but whatever experience you will be getting during your PhD, that is going to be applicable in other fields. Okay, so when you have decided to continue for your PhD program, you please make sure that you have a very good fundamentals, because fundamentals will never change, right? So you should have very good fundamentals on that particular area. Okay, now how will you develop those fundamentals? Of course, before PhD program, you must have done your bachelor's degree. Okay, it may be in engineering, it may be in arts, it may be commerce side, anything, right? But after once you've decided to continue for a PhD program, you have to take some kind of a courses. So most of the universities culture, they ask you to take some of the courses in the given area. Okay, what are the courses? So here I'm mainly talking from the IIT point of view, which is a engineering institutions, but depending upon your profile, management profile or arts profile, you still need to take a lot of courses here. Okay, so for example, in IITs, we ask our students to take a lot of courses, okay, especially about a mathematics course, because that is going to be one of the key aspect of any PhD problem. Okay, so you take basic mathematics course, okay, you take advanced courses, okay, then these are the courses, for example, finite element model, okay, or CFD for computational fluid dynamics. These are needed for design point of view, right? So for example, if you look at FEM courses, whenever you want to like to design a prototype or experimental setup, okay, you like to know what are the standard condition here, what are the failure criteria on that thing. So you design a setup on first a CAD, which is called computer aided design. Okay, so for that we have a different kind of softwares, and after that you carry out a detailed analysis part. Okay, so these are some of the courses. Then if your research work is going to be on the experimental side, right, hands-on experience, then you have to take these courses like design of experiments or design methodology, right? So every branch has these kind of a specific courses which basically tells you that how do you basically carry out your experiments, right? How many experiments you need to carry out, what should be the priority order for those experiments. Okay, so if you have n parameters, then how you're going to really optimize so that you can get the desired results without using the resources up to the extreme limit, because in many of the experimental conditions the resources are limited. Okay, your machines are limited, so the objective here is to complete your given objectives with a minimal resource possible. Okay, so that's something. If you are working on a numerical problems for simulation related problem, then you have to take numerical analysis course, data analysis course, measurement courses, and so on. Okay, so depending upon institution, you have to take a lot of courses. So I always recommend my students that PhD is always a learning process, right? So it does not mean that you have completed your first year, so you should not take a courses. Okay, so PhD is always about learning. So take as many courses as possible, because you never know that what kind of courses are going to be useful when you go outside the institute for your postdoc or for your industry experience. Okay. So relevant courses, keep attending relevant courses throughout the study. That is going to be very useful for many of you. Okay. You also need to speak to other researchers. Okay. This is very, very important. Sometimes what I've seen that also here in IIT, that the graduate students, they're only staying in their own lab, right? They're only spending most of the time with their own lab mates. Okay, they do not have really that much interaction with outside people. What happens is that all the thought process are going to be limited to that particular laboratory, that particular researcher, which may not be very useful. Okay, so for example, if you are stuck in some kind of a problem, right? If you discuss this problem with other researchers, maybe from other department, okay, or other research groups, then you will find something which you have not even thought about. Okay, so always this in management we call as an out of box problem, right, or out of box solution. So what does it mean? Okay, it means that if you're staying in that laboratory with similar people, you will only think solution from this box, right? So you have to go outside lab, out with other people, and then only you will come out with this kind of a solution. Okay. One more thing is that just a suggestion, right? So when you attend any kind of a talk, any kind of seminar, you might have noticed, right, that sometimes people say that learning is also a very, very important skill, right, which is often ignored in the PhD thing. Okay, learning is very, very important skills. Okay, why is that? Because in any kind of a discussion, if you're only speaking, right, so when you speak, you learn whatever you already know, right? But at the same time, if you listen to others, right, you know something very new. Okay, so it is always very idea to attend as many seminars as possible, as many other talks as possible, because there is definitely something new which you are going to learn about. Okay, right. So now let's look at what is the major steps, okay, in PhD problem. Okay, so as I said that this is the very first step is going to be the literature review. It means, okay, you like to find out that what is going around. Okay, so in a given area, what is the current status, what the other researchers have done so far. Okay, what are their approaches, what are their results, what kind of loopholes they have. Okay, so in any PhD, most of the PhD research problems which we have seen is about filling those loopholes which are visible during your literature review. Okay, so literature review here, okay, as I said that this is always a ongoing process. Okay, literature review never stops. Okay, so from your first year, okay, this is year 1 to your whatever is your duration of the PhD study. Okay, it is always a ongoing process. Okay, you have to maintain a kind of this kind of skill to find out what has been happening in your area, what are the new publication that has come out in that area. Okay, so that you can find out, okay, whether you are following the right approach or not. Okay, so in the first year when you are carrying out a detailed literature review, okay, you will find out that person A has done this thing, person B has done this thing, person C has done this thing, and so on. Then you need to find out that what are the shortcomings. Okay, what are the loopholes in this approach, what is the loopholes in this approach, what is the loopholes on this approach. Okay, so once you carry out a detailed literature review, you will basically summarize all those loopholes, and then that is going to be the basic of the defining a research problem. Okay, if you are lucky enough that your project is already funded project, that problem is already well defined. But if you have to define a problem, then itself is going to be a critical task. Okay, so if you have a clearly well defined problem, that is going to really help you a lot. You are going to save a lot of time. But if the problem is not well defined, okay, then you need to carry out a extensive literature review. Okay, so when you are defining this kind of problem, you have now chosen a kind of a problem area that I'm going to work in this particular area. For example, let's say sensor, right? So you need to decide what is going to be your research objectives. Okay, for example, my research objective is to fabricate a chemical sensor. Okay, or I want to develop a methodology, experimental methodology of a already developed sensor. Okay, or I want to carry out a extensive study about the effect of that sensor, something like that, right? So defining a research objective is also a very important thing, and that during this process you have to be realistic. Okay, my advice is, okay, that be very realistic that what you can achieve within this particular time frame. Okay, if you have basically proposed a very high standards, okay, and if you are not going to meet up, you are going to be disappointed. Okay, so it's always a good idea which in management say that promise less and deliver more. Okay, if you are following this kind of approach, okay, then of course that is going to be very beneficial in the long term. But at the same time, you cannot really make your standards too low. Okay, so you have to form this kind of a balance. Okay, so find out what are the literature review, what are the shortcomings, define a research problem, okay, and then define a research objective. Now, let me tell you that this research objective, which we are going to set up in the year, end of the first year, they are allowed to be changed. Okay, so research objective which you have defined in the first year versus the 5-year, okay, they are going to be different. Okay, but there should not be a drastic difference that you started with something else and you are going to end up with something else. Okay, normally that is not really encouraged from that point of view, right? So now you have defined your research objective, so you know that whether you are going to work on an experimental problem or the research problem is going to be numerical or analytical based thing. Okay, so according to this study, you have to take the corresponding courses and build up your strong fundamentals here, right? So while designing your experiment, okay, you have to understand what are the resource constraints. It means that if you require any kind of a hardware, okay, any kind of machine, whether you have the accessibility to that machine or not, okay, you have to really find out. If you are going to use some kind of consumables, you also need to figure it out what is the cost of the overall consumables so that you can plan accordingly. Okay, so this is very important. Okay, you have to keep in mind. Now, important thing is that, of course, when you are going to carry out your experiment or your simulation thing, you are going to get some this kind of results. Okay, and these results you need to publish it. So publication is a very important outcome or measurement of outcome within India. Okay, so you have to be a bit aggressive from that point of view. I'm sure that most of the supervisors who are here, they are also like to publish a lot. Now, on this particular point, you have to remember that my advice is that try to focus on getting good publication. So I will tell you that thing in little bit detail when I'm going to talk about my editorial experience and what are the objections which I have seen it here. Okay. Now, when you talk about the publication, okay, there are two approaches. Okay, so one approach is that some people, what they do, they try to make a report or try to formulate a manuscript and try to publish at say like after a couple of years. Okay, it means the publication goes simultaneously, okay, with your experiments, with your PhD progress. Some people, what they do, they try to complete their work, okay, and only after that they like to publish. Okay, so they have a multiple publication at same time, while in the first approach you are getting, let's say, 1 or 2 publication after second or third year. Okay, so both approaches are fine. Okay, so depending upon your own discussion with your supervisor, okay, you can choose either this one or that one. However, I would say that this particular first approach is going to be beneficial. Okay, why is beneficial? Because if you are getting a simultaneously publication after 2 or 3 years, okay, you get this kind of a morale booster, right? You know that whatever work you are doing, okay, it has been peer reviewed by a journal and it has accepted your findings. Okay, so it already means that there's some kind of a worthiness in your research work. Okay, at same time, when you submit your thesis, by the time you already have a couple of publications, and the thesis examiner, they have a very positive outlook on this aspect. If you have already a published publication, then that is thing has to be seen from a very positive angle. Okay, but if you do not have any kind of let's say publication or publications are few, then it means that your thesis is going to be examined more carefully because that has not been reviewed by other researchers. Okay, so publication is going to be a finding, and after you complete your study, you need to convert that particular finding in kind of a monograph, which is we call as a PhD thesis here. Okay. So now let's look at things in a bit more detail about the literature review, right? So as I said that what is going around, literature review just tells you that where exactly you are standing. Hmm? What is the current findings about the other researchers? What is the current groundwork? Okay, and what is happening within a institute within India or outside India? What are the research groups? Okay, so once you complete this kind of literature review, you should able to tell that what are the research groups which are working on this area. Okay, what people have done it, what people have not done it, and so on. Okay, so remember that review process is going to be a kind of a time consuming process. Okay, if you read any kind of a paper, it is going to be time consuming, and as I said that this process is always a going on process. Okay, so it never ends up. So my initial recommendation is that you have to start with something called as a review paper. Okay, so if you look at any kind of research article, okay, always start with a review paper which is published in a good high quality journals. Okay, so journals are also, now I will come back to this point again later on. Okay, there are some good journals, there are some not so good journals. Okay, so try to find out a good review paper which has a high number of citations. Okay, and once you go through this good review paper, you will kind of get an overview idea about that particular research domain. Okay, you can also subscribe to Google Scholar, where you can put up a particular research area, particular research domain. Whenever any new article in that area will come, you will get an automatic notification. Okay, so this is a very good facility which has been initiated by Google Scholar a couple of years back. Okay, so if you do that, you will be notified about a new findings, new research area which is coming in that particular domain. Right? Now, a very important thing here is that, okay, let me go to this slide first. Okay, so a very common mistake what people do, okay, that they simply go through the paper, okay, without understanding it. Okay, so that is okay for the beginner ones, but after that, okay, you have to understand that particular paper. Okay, so reading paper is not only enough. Okay, you have to pay attention on what is the content, what exactly has been described, so that if your supervisor is asking you that what is this particular paper is about, right, you should able to give this kind of a summary of that particular journal article. Okay, you don't have to just read it. That's why this is very important. Okay, and you have to, this is a kind of a common mistake most of the early PhD researchers do. Okay, they simply go through the paper line by line, okay, without understanding about the technical terms which has been utilized in that. Okay, so there are two things. You have to understand the technical things. At the same time, you should also understand how that particular article has been written. Okay, what kind of language has been used. Okay, in abstract, for example, are they using a present tense or past tense? Are they using a passive voice or active voice? Okay, how they have made a story in the introduction, right? So all these things you will be getting it after carefully reading that particular article. Okay, so you have to understand the particle. That's very, very important, both from the technical side, but also how that particular journal article has been written. Okay, because once you start writing your own manuscript, you will have a lot of problems. You will have a lot of thought process, which I will come a little bit later. Okay, so article is like a kind of a compilation of your understanding. Okay, so read a article. Okay, understand the status process, what is the current trend. Okay, what are the loopholes, right? What are the shortcomings of that particular paper? Now let's say that you had find out about that particular shortcoming. Okay, you also need to find out whether that particular area is being going on by other researchers or not. Okay, because most of the researchers, most of the graduate students, they are following the same approach. They are also reading the papers. Okay, they are also trying to find out the loopholes. They are also trying to plug the particular loopholes. So you need to find out whether there are any recent papers, okay, published in that area. Okay, it is always a good practice to make this kind of a summary report. Okay, I would suggest some kind of a small PPT slides which you can show to your supervisors. Okay, so a short PPT, maybe 1 or 2 slides only, okay, should show what are the key findings, key problems, key issues reported in that particular article. Okay, and later on, based on the number of articles which you have presented, okay, you can basically document, you can write your own report about those published articles. Okay, now what we do is that so when you carry out your literature review, okay, you are testing your reading skills. Okay, you are also trying to understand what is going on thing. Once you complete, you make this kind of report writing, you will be also utilizing your writing skills, and when you're presenting it is about your speaking skills. So when you complete a literature review and presenting the finding of that article before your supervisor, you are basically testing all of these skills. Okay, so you have to also understand and also try to improve about your communication skill. Okay, so let me tell you that communication skill, or to be precise, technical communication skill is not about whether you know English or not, whether you can speak fluently English or not. No, it's not only about the skills, but about the reading skills. Okay, right? Whether you can find out the key findings of that particular paper, okay, as quickly as possible. Okay, now what I have observed here, okay, that many of the research students, okay, they start writing their own review article, okay, based on the literature research. So for example, if you have an area, okay, you have gone through, let's say 20, 30, 40 papers, okay, you are in position to write your own review articles, okay, based on that particular area. Okay, this is also a very growing trend, and I recommend this kind of trend because once you have completed a literature review, okay, you can basically test your own skills by writing a review articles on that area. Okay, so now as I said that you have gone through, completed your literature review. Now you have defined a research problem. Okay, research problem can be either an ongoing problem. So for example, if you have joined a research group which is already working on a particular given area, so you may be possible that you are continuing a research problem which has been tried by your early senior researcher, right, or senior student. So the problem could be ongoing, or it could be a kind of a completely new problem. Okay, so you can have a, if you look at from the contribution point of view, okay, it could have a kind of an incremental contribution. Okay, for example, that let's say that if you can make the efficiency, for example, everybody is excited about solar cell, right? So if you look at the solar cell, okay, the efficiency is roughly about 20 to 25% currently. Okay, but suppose you do some kind of a modification, some kind of addition, and if you increase this same solar cell field efficiency to, let's say, 30 to 35%, okay, that is going to be kind of a significant addition to an area which is already known, right? Or your research could be path breaking totally. So to just give you idea that people are working on a flexible solar cell. So if you look at solar cell, okay, we have been using silicon solar cell, but right now people are also talking about this kind of a transparent flexible solar cell which you can attach to your window. Okay, so this research is already happening here. That's why we are calling as a kind of a path breaking thing. So if it's really successful, it is going to have a lot of new knowledge. Okay. In the previous seminar, Dr. Chatterjee, she has mentioned one very important thing, okay, that whatever you are trying to do, okay, any product, it has to be useful. Similarly, the PhD problem on which you are currently working on, okay, it has to be some kind of a usefulness, right? Either it has to be useful to industry, or it should contribute to the basic science knowledge. Okay, so you have to be very, very clear about it. Okay, if you are not able to find out any kind of let's say application then you will have a difficulty in answering this question if somebody asks you that, okay, you have completed your PhD work, right? But how this particular technology, your PhD is going to be really useful. Okay, so you have to be very clear about this particular idea. Okay, right. So when you have selected a problem, finding out, like I said in my previous lecture slide, okay, that it is very important to carry out literature review continuously. Okay, because why? Because world is so big, it is very much possible that somebody else is working on the same problem. Okay, so I gave you example of solar cell, right? It is very much possible that somebody else is trying to do on similar kind of idea, and if they are successful, then of course the credit will go to them. Okay, so a literature review should be very continuous. Okay, so like here. Okay, so if you look at this slide, okay, so for any given problem, okay, there could be a multiple solution approaches. Okay, you can basically increase the efficiency of solar cell by changing this metal layer, or you can increase its efficiency by increasing the surface area, for example. Okay, so there could be multiple approaches for a given problem. Okay, so you have to do this kind of a continuous literature review. Why is that? Okay, you are working on a topic and suddenly you see a paper, okay, journal article, paper having the same title which you are going to give to your thesis is already published. Okay, somebody has already done it, then what will you do? Now you are in the middle of your PhD, right? You cannot change that PhD, right? So if you can find out this thing by doing a extensive literature review, that thing is going to be really useful. Okay, so I always recommend about these things, that please keep on following. You should know who are your competitors are, what are the prominent research group in that area. Okay, and you have to keep an eye over that. Okay, so in research world, this thing is unfortunately true, that whoever published first, okay, normally the credit goes to them. Okay, so any kind of a fast publication is going to help you, because if you are among the first few, okay, then you can claim that, oh, I have published this thing literature early, okay, and this is going to be my research problem. At the same time, okay, you are also telling others that this is my domain. Okay, IIT Bombay, for example, is working on this area. Okay, and these are our results. Okay, so this from that point of view, this fast publication or simultaneously publication approach during your PhD is a recommended technique from my point of view. Okay, so like I said, you have now a problem, research objective. Okay, and I'm sorry, I've already mentioned that. So when you defined your research objectives, okay, in the beginning of your PhD study, and when you compare it at the end of the year, okay, it is very much possible that those objectives are different from the earlier ones. This is very okay, but they should not be drastically different. Otherwise, the committee, RPC committee, which we called here in IIT Bombay, is called Research Progress Committee. Okay, the committee which is responsible for monitoring your progress. Okay, so normally if you are deviating too much from your given objective, they are the one who are going to check about it, and they will tell you that do not go beyond a particular variation. Okay, so idea here is that if once, how do you define research objective? So you have a research problem, you can break into small pieces, right? You can piece it 1, 2, 3 or 4. Okay, and break the problem into 5, let's say multiple pieces, 3, 4, 5 and so on, and each of these small problems becomes objective. Okay, so for example, it could be, let's say, numerical analysis of a problem. Okay, then you will do experiments. Okay, then you do this kind of validation. Okay, then you validate with the earlier published data and so on. So this could be a basic of your research objective. Okay, And once you break this bigger research problem into smaller pieces, okay, it is easy also to tackle a small problem compared to the big ones. Okay, you can also define some kind of a timeline, okay, that I will complete this work in a 6 month, experimental will take, let's say, 1 year, okay, this will again going to take 6 months, and so on. So that will give you some kind of an idea that how do you follow your research journey. Okay, if you are stuck in somewhat in area, then at least do you have any kind of plan B, okay, what to do in case the machine is broken down, okay, whether you can do a first the simulation thing or not, and vice versa. So these, all these things will be useful in meeting your objective within that timeline. Okay, so timeline is fixed, 5 years of your scholarship period. Okay, within that particular objective you have to complete your things. Okay, it is also a useful thing to define a flow chart. So for example, this is your research problem. Okay, here you will do your numerical part. Okay, then you do experiments. Okay, for example, the experiments, if experiment results is matching, you will proceed well. If they are not matching, then you will go back to simulation and you will try to change some of the variables and see whether they are matching or not, right? If you're matching, then you will do this kind of again validation. Okay, so this kind of a flow chart, if you make it, it is going to help you in following your own research progress. Okay, now I will not go in detail about whether you should go for experimental research problem or numerical problem. Okay, this will be depending upon your research domain. Okay, what your background, whether you are good in mathematics or you like hands-on approach. Okay, so depending upon your own research interest, okay, this thing is going to be carried out. Okay, so both experimental research work as well as the numerical research work is going to be beneficial. However, this COVID situation has taught us new things. Okay, so I would say that hybrid approach, okay, is better. So for example, let me just tell you at my own research group here in IIT Bombay. So I'm mainly working on the experimental side. Okay, but because of this COVID lockdown, many of my PhD students were sent back. Okay, typically for up to 6-7 months, no work has been done. Okay, but I was fortunate enough that some of those students were good enough. Okay, what they did during their stay at home, right? They started making a numerical model. Okay, numerical model of the process. Okay, so once they are here, once after the lockdown, what they did quickly experiment thing. Okay, and they have checked whether this experiment data is matching or not. Okay, so looking at this kind of situation, okay, a pure experimental or a pure numerical approach, they have certain limitations. Okay, and it's always a good idea to have a little bit of both. Okay, so you can have, for example, 70% experimental work and 30% numerical, and vice versa. Okay, whatever you do, that particular hybrid approach is going to be useful things. Okay, that is why this is going to be kind of a recommended here. Okay, but this is again depending upon area to area. Okay, depending upon the whether your institute has the resources or not, whether you are working on, let's say, IT related research areas and so on, you can pick up your own research topics. Okay, when you designing, when you do carry out your experiment, okay, again this is very important. You should know, you should have a very clear idea that why you are doing these experiments, what are the objective of this experiment. Okay, whether you should have some kind of prior idea that if you do this kind of experiment, what are the expected results. Okay, you should find out what are the independent variables. Okay, and what are there going to be outcomes. Okay, one of the very important aspect in any engineering study is going to be what we call as a design of experiment, or DOE. Okay, design of experiments. Okay, experiments. So this is called DOE. This kind of a thing is very useful. For example, if you have a many variables, right, and if you want to see the effect of each individual variables on an output, okay, the number of required experiments are going to be very high. Okay, and many times it is not possible for any research student to carry out and repeat those experiments, okay, because of the limited resources. So in those kind of situation, having a kind of a statically well-defined DOE is going to be useful. Okay, so you define what are the important parameters, what are the relevant parameters, okay, and you carry out your own first experiment with the right set of number of experiments. Okay, so there are many approaches. So what I'm saying is that this kind of a full factorial experiments, okay, which where we require DOE. Okay, if the variables are not too many, then of course you can vary one parameter at a time, and you will see the individual effect of that particular variable. Okay, so DOE is always recommended because in the first approach you will have no idea about how the two independent parameters are going to affect each other. Okay, so whenever you are involved in any kind of experimental based research, okay, it is very important to carry out the same experiment multiple times, okay, at least 3 times. Okay, so each experiment, okay, they need to carry out at the same conditions multiple times so that we can check whether the results which we are reporting are they really correct or not. Okay, is it not a matter of luck, for example? Okay, so it is always recommended, and whenever you submit any manuscript, those journal editors and reviewers, they always ask you to plot. There's something called error bar. Okay, so error bar means if somebody is asking you to include error bar, it means that that person is questioning on the repeatability of these experiments. Okay, so you have to be extra careful, okay, because if you do going to perform multiple experiment, okay, then all the conditions, okay, experimental condition, the person who is doing this experiment should be same. Okay, so each experiment ideally they should be carried out identically. Okay, so even though you carry out the same experiment 3 times or multiple times, okay, under the same condition, there will be some kind of a variation in the output. Okay, and that particular variation in the output should be plotted as a matter of a variation in the, that is what we call as a error bar. Okay, so if you are performing, or if you are showing error bar in the experiments, it automatically means that you have carried out multiple experiments. Okay, and these results can be trusted. Okay, so now the question is that what is a good experiment? Okay, so good experiments, okay, basically should have solid understanding with the theoretical trend. Okay, it should not happen that you have done some experiment and it is basically going against with the natural law. Okay, no, right? So a good experiment, like I said, it has to be repeated multiple times. Okay, so typically because of the lack of resources, okay, at least you need to carry out 3 times. Okay, right? So you have to be repeat experiments, okay, to prevent any undesired variation. Okay, ideally there should be as low as possible variation in the output. If there's a variation, is a large variation, it means something is not going in a correct fashion. Okay, so for example, any variation within plus minus 1%, that is considered from an industrial point of view. Okay, but in academic world, okay, variation plus minus 5% is going to be okay. It is considered to be okay, right? Anything if the variation is going to be like plus minus 20, 10%, 20%, then it means that the experiment has to be repeated. Okay, something is causing that variation, and you need to find out what is the root cause behind that particular variation. Okay, if you, let's say that you have come out with some kind of process parameters, okay, if somebody else in some other institution is using those parameters, okay, they should get similar results. Okay, for example, I am performing here in IT Bombay, okay, and if I share the same Professor Daspi to Sardar Patel College of Engineering colleagues, right? If they are doing experiments, okay, they should also get the same results with what we are getting. If this is not a case, then it means that my process is not universally transferred. It has some kind of a local dependency. It is equipment to equipment variation. Okay, so this is not considered to be a good idea if there is going to be some kind of a process variation. Okay, right. So now next question. Now you have done experiments. Okay, now after that you have got some of the results, and as a part of your academic program, you have to you have to publish some of the articles. Okay, so now let's talk about this thing. So since I'm advocating a lot about a good literature review, so if somebody has performed a good literature review, it means that the graduate student is fully aware of what are the reputable journals, okay, what are the good journals, and what are the not so good journals. Okay, right. Now what are the good journals, what are not so good? Okay, this criteria is totally depend on institutions. Okay, so for example, many of the NITs and private institutions within India, they simply say that journal should be Scopus index or SCI index. Okay, but here in IIT Bombay, for example, okay, we do not consider this the only criteria or the whether a journal is good or bad. Okay, so many, like I said, many institutions, even NITs, are not careful about this area. As long as they are publishing in a SCI or Scopus index journal, okay, they are fine. But believe me that this is not. There are many not so good journals which are published in Scopus index. Okay, so my point here is that, okay, as an institution, okay, you are not only representing yourself, right? You are basically presenting your own institutions. Okay, so my recommendation is that try to submit your research work in a well reputable journal, okay, which has been properly peer reviewed, okay, in which the reviewers are providing you a very good feedback on your work. They are properly positively criticizing you so that you can improve on. Okay, so once you carry out a research work, these graduate student or any researcher, they are fully aware is that what is the true quality, what exactly is the quality content of their work. Okay, that is very, very important, right? Because I am the one who has done my experiment. I know whether these results are good or not, how these results are comparable by other standards, right? So if I feel that my results are good, okay, I should definitely try to send this manuscript, these results, to a good journal. If I see that, okay, my results are not so good, these results have been already published in other areas, then I should try to include some kind of a novelty here, right? So first of all, you should be confident of your own research work. Then you should ask yourself, can you defend once you submit this kind of results, this kind of manuscript, okay, the reviewers, the editors, they are going to criticize your work, right? So the question here is that can you defend this your work against the editor and the reviewer? That's a big question. Okay, and in order to defend that, first of all, you should be confident about your own things. You should know what exactly is the quality content here. Okay, you should able to answer that how does this work contribute to the already existing knowledge. Okay, have you done any kind of methodology, or have you changed any variables, or have you brought some other novel content which has not been reported by others? Okay, now what is the similarity criteria? Okay, now everybody is talking about plagiarism, right? If you look at within India and outside world, there's a lot of debate is going on plagiarism. A lot of journals, even from a reputable institution within India, have been caught in this kind of a controversy. Okay, so being a part of this editorial board, I can tell you that every reputable journal, they have their own plagiarism software check. For example, this kind of a Turnitin. Okay, This is one of the popular plagiarism software check. So once you submit any manuscript, okay, these journals or these reputable journals, I would say, okay, check your manuscript against to whatever is already published. Okay, if the similarity conduct whatever is the index, okay, beyond a critical value, okay, editor will do something called known as a desk rejection. Okay, only if this similarity index lies within some value, then only you are going to forward that particular manuscript to a reviewer. Okay, so before submitting your manuscript, I would recommend everybody to go for this kind of similarity check to the existing this softwares. Okay, now let's talk about some of the preparation steps. Okay, so now you have already completed your work. Now you have a lot of results. Okay, and only thing what is written left is going to be writing manuscript. Okay, but believe me, this is not going to be the easy task. Okay, let me show you this this slide first. Okay, so transferring thoughts on paper is not an easy task. Okay, you have done a lot of experiments, right? You have experimental results. The only thing you have to now do is transferring whatever is in your mind on paper. Okay, but it's not that. Okay, it's not easy task. Okay, if you're not able to transfer your results, okay, your work in a clear written document, okay, it is not going to be useful for others. Okay, so this is a kind of a practice which you have to do, and only after doing this kind of exercise, practice exercise, then only you will learn this kind of art, that how efficiently you are able to write or how efficiently you are able to transfer your thoughts on a paper. Okay, so that is not going to be easy task. So what I always recommend to my students, whatever is coming in your mind, just keep on writing. Okay, because nobody can really write a perfect manuscript in the first few attempts, right? So whatever thoughts is coming in your mind, okay, whatever is the flow, you just write down on a paper, and only after some time you basically worry about, okay, what you have been writing on. Okay, so I'll come back to this point again a little bit things. Okay, so so like I said, transferring your thoughts on paper is a time consuming process. It's not easy. You will only learn about after a few iterations. Okay, but suppose you have written some kind of a draft manuscript, right? You can ask your colleagues, your fellow PhD scholars, or your faculty colleagues. Okay, you can ask your colleagues to think from the reviewer point of view and try to positively criticize you. Okay, so don't worry about the criticism. Okay, if let's say that your colleague is telling you, no, your work is crap. Okay, don't start fighting with them. Ask them that why do you think that this work is not useful. Okay, so whatever suggestions they are providing to you, okay, you have to take it very positively. Okay, because any kind of a criticism is going to add certain value to your manuscript. Okay, so I always say this thing, that when you are submitting your manuscript, when you are publishing papers, you are not only representing yourself, but you are presenting to the research phase of your institution and your country also. Very important. Okay, recently if you see that there are a lot of plagiarism based paper is coming from India. Okay, so what happens is that because of this kind of a problematic area, a lot of other researchers, they face this problem. Okay, many people say that they see that, oh, this paper is coming from India or China. Okay, then this paper, they go for a extra scrutiny of your paper. Okay, so you have to be very clear about that. Okay, so while writing your manuscript, okay, you have to check about these 4 points. Okay, fabrication of data. Okay, you need to make sure that you are not reporting any data without doing an experiment. Okay, that let's say that I wanted to plot for 3 variables. Okay, I just taken only 2 variables, third variable I have not taken it, and I'm making this kind of a plot by without doing experiment. That is totally wrong. Fabrication of data. Okay, falsification of data. Okay, you are putting the improved numbers. Okay, so my, for example, solar cell efficiency is only 5%. Okay, I'm reporting as a 10%. Okay, so that is going to be completely wrong. Okay, plagiarism means, again, you are taking somebody else's data, somebody else's picture, somebody else's results without giving a proper credit. Okay, that somebody else can be your colleague also. Okay, let's say that couple of students are working under same professor, right? And you have taken the image, the picture of your fellow students, okay, without giving him a proper credit, then also this thing is completely wrong. Okay, so plagiarism is a kind of these points. Final point here is that it is the responsibility of all authors to check about these two. Normally what happens is that if you see that author number 1, 2, 3, normally the professor is outside here. This is a lead corresponding author or professor, right? Many times it happens is that professors, okay, I'm talking about in a general term, okay, they do not really check about these points, okay, and this basically cause a lot of problems if something raise any concern about the authenticity of that particular work. Okay, because corresponding author is responsible because he is doing correspondence to the editorial team. Okay, so it is the duty, it is the primary duty of a professor or faculty in charge to check, okay, whether all manuscript is free from these points. Okay, they cannot simply say no, this is my student has done this work, that's why he is responsible. No. Okay, it is the responsibility of a faculty member or any kind of a wrong things which may appear because of a casual mistakes by the students. Okay, right. So I would say that okay, classical dilemma, like I said, many of the students, they always ask this first question: shall we go for a quality or quantity? Okay, whether we should publish like a few high impact factor journals, or should we go for a large number of papers with a mediocre quality. Okay, so this decision is basically up to the principal investigator or the faculty in charge. Okay, more importantly, I would say that one of the thing is that impact factor alone should not be the whole sole criteria, right? So many of the, if you look at the many of the journals which are emerging in all the engineering fields, they have a very high impact factor. Okay, but if you look at, for example, IEEE transactions, okay, which is having a very reputable journal in field of electronics and computer science, they have typically impact factor less than 3. Some of them have less than 2 also. Okay, but it's very difficult to get into those particular transactions. So impact factor is not the criteria. You should find out that what is the history of that particular paper, what is the ranking of that particular journal paper, from how many years that particular paper, journal is being published. Okay, so based on all these things, you have to take kind of a decision. Okay, so many of the people, they follow this kind of a approach that they first publish their paper in conference paper and then they will go for a journal things. Okay, personally I would say that reverse thing is better. Again, this is my personal opinion that okay, I always recommend my students to submit their new work which has not been reported to first journals and then to conference kind of articles. Now, why is that? See, the conference papers or conference articles are mainly preferred by the industry people, okay, because they would like to show that their new results, new techniques to their competitors, and also they try to find out the new customers. Okay, but for a research students, especially for the early research students, okay, it is not that much useful. But yes, if you are almost about to complete your PhD and you like to know about postdoc opportunity or a good point of view, then in that particular case, attending the conference are definitely going to be useful. Okay. I would say, okay, so let's talk about a little bit thing about how you make this draft manuscript. Okay, so while so you have now find a particular journal paper which is basically meeting your criteria, you have find out the reputation, you find out what is the acceptance rate. Okay, there are some journals which are only accepting 10% of the submitted manuscript. There are journals which are acceptance rate is almost as high as 80 to 90%. Okay, so 80 to 90% means that something is definitely fishy in those journals. Okay, there are some papers or articles which takes less than 1 month. There are equally good journal paper which are going for beyond like 10 12 months also. Okay, so based on these criteria you can find out a target journals. Okay, once you had figured it out in which journal you want to submit your manuscript, okay, I would recommend try to find out similar papers. Okay, and try to look at how they have written that particular style. Okay, so style means that, for example, how they have written their abstract, how they have presented their experimental data, so that you have some kind of idea that how you should write your own results. Okay, so you should try to draft your own manuscript according to those research articles which have been already published. Okay, sorry. So give me 1 minute, please. So if you look at the preparation order, right? So main thing is that the audience, the readers, they would like to know what is the special thing about this work, right? What is the novelty? What is the improvement? Okay. So in that case, remember that you should put more efforts. The significant portion of your manuscript should be on the results and discussion section. So if you look at any manuscript, typically you have an introductory part. Okay, this is introductory part. Then you have numerical simulation. Third thing is going to be experimental details. Fourth is going to be results and discussion. These are like 4 parts. Finally, you have summary and conclusion, right? So these are the 5 main parts. So I would say that more than half of your manuscript should be devoted to the results and conclusion section, because this is what the readers would like to know about it. Okay, so this is my personal preference order that I always ask my students to first complete this result and discussion section. Okay, because they are comfortable with experiments, they have done experiments. Okay, after that they should write experimental details, and after that they should write introduction, and finally they should write conclusion section. Why is that? Because like I said, students have done all the experimental work, they know what are the results. Okay, they are fully aware of the literature review, they know how this particular results is different from what has been already been reported. Okay, so they are very comfortable with that. Okay, so then they should write simulation results, and finally they should write introduction. Now this introductory part is going to be very, very important, because this basically tells, so introductory section should write down the motivation. What exactly is the need of this work, right? Why we are doing this work, whether this particular work is useful or not, we have to really mention this thing in the motivation part here. Okay, objective has to be very, very clear, and ideally should be highlighted in a bullet points. Okay, so all these objectives should be right in the bullet points, so that reader can clearly indicate that's 1 2 3 4, these are the 4 objectives of this work which has been doing into. Similarly, the concluding part is that conclusion, okay, it should also be written, okay, preferably in a bullet points also. Okay, and remember that conclusion should not be only summary of what you have done. No, conclusion should include what is the outcome of that work, and that work outcome has to be indicated in a bullet points here. Okay. Abstract, so abstract is just like your cover page of a book, right? So you should basically cover the entire theme of your manuscript, and ideally should be written at the last. Okay, when you have already completed your results, already have completed your introductory part, you are very, very clear, then you should write down the, like, summary of the entire thing in the abstract. Okay, so all the key findings has to be mentioned in the abstract itself. Okay, because many times what happens is that many journal articles, they have some kind of a limit of abstract, that abstract should not be more than 100 words, in some cases 200 words, and so on. So you have to be very, very miser while choosing the right word here. Okay, so I think I've already mentioned to you about this exercise. Okay, so whatever coming while you're writing a draft manuscript, right? Sometimes you have this thought that this sentence should be written down by this way. Okay, so my recommendation is that whatever is coming in your mind, so start writing down on a piece of paper. Okay, and then see whether you can clearly indicate that particular thing. Okay, so before actually writing, okay, you should create this kind of a flow chart. Okay, because writing a manuscript is just like a telling a story. Okay, if you are a very good storyteller, people will enjoy it. Okay, if you're not very good storyteller, if you're not able to really indicate clearly, write down a manuscript, people will not be enjoying your work. Okay, so write down a manuscript, write down the flow chart, that how you wanted to convey, what are the important points you will write in the introductory part. Okay, how this work is going to be different from others, all these points you have to be extremely clear, then only you should be able to write down any manuscript very, very clearly. Okay, so I already mentioned to you about this thing. Introductory part, it should be the snapshot, should be written in the last. It should be very, very precise and at the same time informative. Whatever the key finding, you should basically indicate here. Okay, when you're writing introductory part, it should contain the motivation, why you are doing this kind of work here. Okay, what is the problem you are trying to solve. Okay, what is the current status, what has been done by others, what are the loopholes. Okay, and how you are planning to fill up those loopholes. Okay, these things you have to be very, very clearly indicate during the introductory part here, because this section will tell you that why you are going to do this work. Okay, then simulation or experimental details, it basically talks about what kind of experimental setup you have, what kind of software you are going to utilize, what are the different parameter variables there, what is the range of those variables. Okay, how many experiments you have done it, whether you have done repeated those experiments 3 times, 4 times, 5 times. Okay, so all those things, how you have measured the output data, what kind of microscope you have used. Okay, all those conditions, okay, you have to indicate in your experimental details section. Okay, finally, I already mentioned to you. Okay, this is your major part. Okay, ideally it should contains more than 50% of the entire manuscript thing. Okay, so what exactly is the output come. Okay, so this is the results. Okay, so if you're only reporting about the results, that is an incomplete picture. You should indicate what is the reason of the scientific reason behind that. If you are getting a result, right, whether these results are making any sense or not, whether they are according to the natural laws or not. Okay, all these things you have to be explained. Okay, if you're only writing that I did this work, okay, and this is the output I have got, it's about an engineering observation. This is not a result, this is not about discussion. That's why the manuscript has this section called results and discussion. This is not only results. Okay, so it means that whenever you are using, okay, any figures or in the tables, okay, they should be properly explained, right, that what is the meaning of this picture, right, what this particular image or results is indicating. You have to indicate all those things. Okay, you need to provide a proper justification. Okay, so for example, you are getting some results. Okay, what is the justification behind that. Okay, if you find that the previously published data also report the similar kind of thing, then you should cite those articles. Okay, right, so if you are saying any kind of a concluding remark, okay, that for example, let's say that the temperature, if you increase the temperature, okay, solubility is increasing, right, so in that case you have to indicate what is the reason behind that, right. If you are not able to find the proper reason, then at least do you have any observation from the prior literature review. Okay, so you should basically write down any kind of a concluding remark or concluding statement has to be properly cited by the prior work. Okay, so these are the few things which we have to indicate. Okay, one more, this is a practical suggestion. that include more relevant references of researcher working in your area, right? What does it mean? So for example, by the literature review, you will know that these research groups are working in this area, right? Okay, so when uh, during the submission of your manuscript, every journalist asks you, do you have any suggestions for the referees? Okay, so if you know, normally what people do, they basically give the names of their friends, right? But I would say that also give the researchers who are working in that particular area, because if by your luck, if the manuscript is going to that particular researcher, he will, or she will be happy to see their work in the reference section. Okay, so that will have a slightly higher chances of acceptance in rate. Okay, so if you follow these previously things, you are going to complete a draft manuscript. Remember, your manuscript is not ready. Okay, it's a draft manuscript. Okay, it has been written by a student. Okay, in that draft manuscript, you have tried your best. Okay, you have tried your best to write down a very good manuscript. Okay, this manuscript will go to your supervisor. Okay, so your supervisor is here. Your supervisor will give you corrections. Okay, so you will go to this thing again, depending upon his corrections, his advice, his comments. You have to do revise your manuscript. Then you again will go to your supervisor. Okay, then again they will give some kind of suggestions. Then okay, so this is this kind of a cycle. Okay, so depending upon how good that supervisor is. Okay, depending upon 1, 2, 3, 4 iteration, it normally happens. Okay, so this is a kind of cycle. Okay, okay, so several iterations are quite common. Okay, so don't worry if your supervisor is asking you third time or fourth time. Okay, it is going to be very normal behavior. Okay, right? So again, one important thing is that, okay, writing a very good draft manuscript and properly revising it, it's your job. Okay, it's not your supervisor's kind of goal, because you are the one who has to complete your PhD, and later on you need to apply for positions. So if you write a good manuscript and if you revise it properly, this is ultimately going to be useful for you. Okay, so this is what we call as a review process, right? Okay, so you are here, you are corresponding authors. Okay, mostly in the beginning your supervisor is a corresponding author. Okay, and here is your manuscript. Okay, you have to reach to this goal, and in this path you have an editor, right? What editor will do? They basically check it whether this particular work or content, okay, what is the similarity index. Okay, if similarity is really a high value, then it is going to be rejected. Okay, if the similarity index is below a certain line, then it will pass through. Then it will go to the associate editor, which is basically kind of expert in that area. Okay, they also do this kind of a review. Okay, then they send to all 1, 2, 3, or 4 reviewers, depending upon reputation of that particular article. Okay, and each job here is to criticize. Okay, remember that they are not your friends, right? Their job is to criticize, so that any kind of a poor publication, okay, or any kind of a faulty results cannot be accepted. Okay, because ultimately, if we allow this kind of any kind of a badly written manuscript, then ultimately what would happen? The quality of the journals will go down. Okay, so this is kind of a review process which are going to be happening here. Okay, so don't be discouraged if you are getting any kind of a bad review. Okay, it is basically kind of a job of a editorial board. But yes, it happens. Okay, that biased, mostly I can say openly here that most of the editors, most of the reviewers are naturally biased. Biased means that, for example, okay, let's say look at the Indian context, right? If I'm getting a manuscript from ISC Bangalore, okay, or any of the IITs, okay, I know that most of these institutions are quite good. Okay, so I will be little bit lenient. Okay, but at same time, if I get a manuscript from a private college, okay, whose reputation is not that serious, okay, I will be a bit more careful, bit more serious, bit more aggressive in reviewing that manuscript. Same thing happens when you go outside. Okay, if you look at the international level, okay, even though we are from IIT Bombay or ISC Bangalore, okay, our manuscripts are having more scrutiny compared to universities which are in top 10 or top 20. Okay, so if you are getting a manuscript from MIT's or Berkeley or Stanford, naturally they will get a little kind of a leniency compared to us. But we should not blame them. Why? Because of their reputation, after so many hard work, they have basically reached to up to that particular level. Okay, so it's naturally it's our job, our high quality work which is going to be useful after a certain number of years. Okay. Let me see. I think this is going to be my last few slides. Okay. So as I said that from the editor perspective, I can share my own thoughts here. Okay. So what happens is that when the manuscript is coming to me as an associate editor in MST, okay, we have this option which basically compares the submitted manuscript, okay, with the similar domain. Okay, it will basically tell you that what kind of similar manuscript have been published in MST, Microsystem Technology. Okay, then it basically checks the plagiarism check. Okay, what is the author's previous work with the prior published by the same author. Many times it happens that we have published one article, okay, then we want to write a second article, and then what we do, we take 10, 20, 30% data from the previously published article without citing them. Okay, then this is again a problem, because once you published a article, you are transferring your own copyrights from yourself to that particular journal. Okay, so although it was your own work, it is no longer have any authority. You don't have any authority over that. Okay, that work now belongs to that particular journal thing. Okay, so you should not cite your own work which has been published in a journal. Okay, this is also considered to be a problem. Okay, so this plagiarism check checks with the other research works. Okay, and we get this kind of number, and many times it happens that many manuscripts are returned at this particular level. Okay, so I think I've already mentioned to you that in spite of having this kind of a neutral claim, many times the author's reputation, institutional reputation, they do better. Okay, so all these famous universities, they get little bit kind of leniency, okay, compared to the newly established universities. Okay, so when this manuscript is coming from editor or reviewer, they first glance through the manuscript. Okay, they mainly look at the pictures. Okay, so I would always recommend my students, and I'm recommending to the audience also here, that try to include good quality pictures. Okay, because if you have good quality pictures, especially in the technical manuscripts, okay, you will have definitely higher chances compared to those manuscripts which do not have this kind of things. Okay, so once the associate editors is find it's okay, then they assign 2 or 3 reviewers. Okay, if there's going to be any kind of split decision, for example, one is telling accept the manuscript, somebody is saying no, okay, then the manuscript goes to another review, and then this is going to be a final one. Okay, so this is kind of a typical review process which is being followed in the different institutions. Okay, now let me tell you that many times it happens that our work has been rejected. Okay, and we feel very disappointed. It's very, very natural. Okay, but at the same time, I would say that a good work, okay, does not always get accepted. Okay, here we have a couple of examples. So for example, the Dr. Peter, who has won Nobel Prize in medicine, okay, this is the award winning paper, okay, work. It was rejected from a Nature journal in 1992, saying that work is not good. Okay, for the same work they have got a Nobel Prize, right? So it means that that work has been reviewed by some researchers, and according to them they did not find it, but of course after that they have found. Again, examples, everybody knows Peter Higgs. Okay, his short paper was rejected in 1964, okay, by physics letters. Okay, after that they've got Nobel Prize. Okay, similarly there are a lot of examples, okay, which where basically the reviewer have rejected their paper, but the work was very, very good and they have got it better results. Okay, so these examples have been taken from this website. Those who are interested, they can find out there are plenty of examples about a good research work which has been ultimately rejected by the committee. Okay, so don't worry about too much. Okay, don't question yourself whether my work is bad or not. Okay, this is the opinion of only 2 or 3 reviewers. Okay, right? So what I would say that take those criticism, those points in positive way, try to see, okay, what are their points, try to improve your manuscript according to their suggestions, and then revise them and submit it again. Okay, so these kind of things, if you follow that, I think there should not be any kind of problem. Okay, of course initial journey would be going to be tough, but later you are going to have any problem. Okay, so with this, I like to finish my lecture here. Okay, I would like to really thank all of you. Thank you. If you have any questions, please do let me know.
Yes, participants, the platform is open for the question. I hope in the morning session, many researchers have the questionnaires about how the design thinking is inculcated with the research. So now this is the opportunity to you to ask the questions. Yes, please unmute your mic and ask the question. Yes, Keshav, please go ahead.
Yeah, hello, sir. So, first of all, thank you so much for the wonderful session. I am from the organizing team, so, take this question coming from an undergraduate student.
Fine.
So, yeah, so basically, I had a few doubts regarding the research as such. So that, what a general pattern that I have observed is that every research tries to improve upon something. Means if the accuracy of a model is say 97%, so the next paper that comes would be 98%, 99%. But I just had this question that whether or not, if we think that there is a hypothesis that we think that, okay, it should work, theoretically it should work. We verify the hypothesis and come to find out it performed terribly bad. So is that kind of a thing be a research topic where we can tell somebody to not go in that that particular direction?
Yes. Okay, it's very much a result. Okay, so in fact, many of these research articles have been written on this kind of approach. Okay, that let's say that you have some hypothesis. Okay, and they have performed this kind of experiment. Okay, and then they have shown it that this particular hypothesis is not working. And if they have also indicated the reasons behind that why it's not working at that, okay, then this is good results. Okay, so results are never good or bad. Results are results, right? So if you can justify your findings with a proper reasoning, okay, then you have basically these results. Okay, the problem is that when you are finding let's say results not meeting up to your standards or your expectations, and you're also unable to find out the reason, then this is going to be a mystery.
Right. So the other one was that you mentioned a point regarding not citing your previous prior published work. So if suppose recently I had I submitted my paper to a conference. Now I know there were a few shortcomings in that because due to the time constraints, I wasn't able to cover a few topics that I wanted to. So now that if I want to work on the same topic, just add the few topics that were left to sort of, complete the research. So as you said that I cannot cite my own work.
Okay, so let me rephrase my statement. Okay, so what happens is that in many conference papers, okay, or let me again rephrase, in all the journal articles and in few conference papers, they ask you to submit a copyright transfer form.
Right.
Okay. Now, if you have signed a copyright transfer form, it means that you are ready, you have agreed upon to transfer the authorship of your work to that particular journal or conference paper, right? Now, if you have done that, then if you are not citing your own work into your next publication, they can raise a concern. Okay?
Okay.
And you are liable to put a penalty. Okay.
Okay.
Now it depends upon this thing. Okay. So if you have a conference paper where they have not asked you to write down a copyright form, then it will be okay. Okay. But from the plagiarism point of view, okay, this is also not considered to be very good thing, that you are showing the same results into a multiple publications.
All right. So like, is that what it means, that if I want to use my own work, I have to cite it that, yeah, I am only the author of this and this was the paper that I took for my reference?
Yes. So, so the bottom line is that if your paper is published somewhere, right? If there is, let's say, in the online form, okay, which can be accessed by anybody, okay,
Right.
then you should basically you should, in principle, you should cite that particular work, okay. Then you are clearly indicating that that work belongs to me, first of all, and that work has already been published, okay, in previous article, and in this manuscript we are reporting something new or addition to what has already been done. Okay, so in the literature review section, it is allowed to include the previously published article of yours and others also.
Okay. So then the next question was that, like, there is this cycle that I have come across and multiple places also. So like, there is, due to time constraints, like you are planning to do some research, or one author is trying to do their research, and what they do is, because of shortage of time, they don't get to finish it completely.
Okay.
But it gets published anyways.
Okay.
Then somebody uses that paper and like they try to figure out, and they also have a time constraint to them, and they also publish like half-baked work. So like this cycle keeps going on. So like, is there any way to for us as like the end who would be publishing papers to like
Okay.
stop or get out of that cycle?
No. This is a very, very bad practice going on in most of the private institutions within India, and also in NITs and also in IITs. Okay? Because of the government mandate of number of publications per year should be so and so, right? So people are basically publishing what is known as a half-cooked meal, right?
Right.
So if you eat half-cooked meal, you will be sick, right? So naturally, what happens is that if the cycle goes on and on, okay, it is going to really make our education system in a very bad phase. Okay, so first of all, what it should be, because there's going to be a professor or faculty or somebody in charge, right? So let's say that in 1 year somebody is graduating it, okay, and he's not able to complete that particular work. So what it is the responsibility of a faculty member, okay, to include that work at the next new work, okay, next year work, and combine them and send a full reputable work, not a like a half-cooked meal. Because whatever time constraint is there, okay, my point is very simple. Okay, we should not really compromise, and we should not really run over this number of publication in Scopus and SCI index journals. Okay, it is really not helping. A lot of things. Let me tell you at this point. So, for example, I am the convener of the postdoctoral committee for Department of Mechanical Engineering here in IIT Bombay. It means that we select PhD students whose application need to be forwarded for final selection. Okay, and during this process, I am receiving a lot of applications from all kind of institutions, including NITs, IITs, and private institutions. And I can see this particular trend that many of the candidates, they have 10, 14, 15 publications. But when you look at the quality, out of those 15, they do not have even a single 1 or 2 articles in a reputable journals. So what will happen? Okay, we simply reject that kind of thing.
Yeah, I would like to just add, Keshav.
Yes, ma'am.
Redundant publications, there is also called as a scientific misconduct, where there is a self-plagiarism and the redundant publications of the same author. So there is a limitation. So I agree with Pradeep sir, just the remaining work, rest of the work can combine or integrate with new, and we can try to construct some concrete statement.
Yeah, very well said, Dr. Sujata. So the correct word is this scientific, misconduct, mismanagement. Okay, because this is a primary responsibility of our researcher. This is something called, academic ethics, right? Everybody knows that, but sometimes and many times we ignore this particular fact. The problem happens that whenever if you follow this kind of a news, there are many organizations whose only job is to find out this kind of articles. Okay, and very recently, a very premier institution within India in Bangalore, medical science, they have been caught in this controversy.
Yes, yes.
Okay.
I hope, Keshav, your doubt is clear.
Yes, ma'am. So just a few more questions, if that's fine.
I am fine with that. No issues.
Yeah.
Sorry, because research is something that I want to do, but again, it's just a little bit of the ambiguity is there. So because of that, I just get very excited. That's why I asked ma'am if I can ask.
No. I am completely fine, Dr. Sujata. I have a lot of time. Yeah.
Yes, yes.
So there was this thing that a common problem that I observed personally. So what happens is that to reduce the plagiarism, so let's say an algorithm was there, let's say WHCA, windowed heuristic, I think, cooperative A star. So this is a algorithm. Now somebody created an optimized version of this. So to avoid plagiarism, they just say that in bracket to describe the WHCA algorithm. And what we did was something like this. So now the point is that I have to go to that paper first. Now, then I have to read the entire paper to get that algorithm and then work here. So, sir, is there any online tool or offline or software tool that is available that makes this transition or switching back and forth easy?
Of course, I'm pretty much sure. See, I'm not from that particular area, but I'm pretty much sure that there are this kind of articles. Okay, this kind of tools are available, which will help you in reducing this kind of a time consumption. Yeah. What I'm trying to indicate that if somebody has put let's say efforts, right, we should acknowledge their efforts by citing them in our article. If we are ignoring their citations, it means that we are first of all ignoring their hard work. Okay, and second thing is that that is not going to be very thing, because it might be possible that somebody else will ignore your case, your paper in future, right? So idea here is that we should have a proper background from that point of view, that on what basis this new improved algorithm is based on.
Okay, sir. So just two last questions. Basically, one was there is corresponding author and there are authors.
Yeah.
So corresponding is the one who is going to the faculty will be our corresponding authors, right?
This is not a rule. Okay. So for example, what happens is that every year students join us and leave it, right? So many of the students, they may not be working in that particular area. Okay, they will basically go to their jobs. So corresponding authors should be that person who is staying in that organization, or somebody who should able to answer any technical question or question related to plagiarism after a couple of years. Okay. So even after 5 or 6, even 10 years, people can question about the authenticity of that particular paper. Okay. So somebody should be there. So normally in the beginning, professors are the one who are kept as a corresponding authors. Okay. So in the initial journals, my students, they have kept me informed, but when they are in final year, I'm keeping them as a corresponding authors, because so that they can learn about the responsibility of these things. Okay. So there's no fixed rule that the faculty should be the corresponding author. No.
Okay, sir. Thank you.
I think other Deepak Sinha is also raised the hand.
Please.
Deepak Sinha, sir.
Yeah, good evening, sir.
Yes, Deepak. Hello.
Sir, as you have already mentioned well in the slide that literature review is an ongoing process. So, sir, I would like to ask a personal experience that I was having when I was doing my literature survey. Like, suppose, sir, initial months when we are doing the literature survey, we are going through a lot of papers. We are not clear in our minds that what has to be done. Like, we are in the process of formulating the research problem, and like around 3 4 months we have invested, we have gone through hundreds of papers, and then suddenly all of a sudden we are going to find out some papers which are claiming exactly opposite of what we have gone through in the initial 100 papers, and they are completely opposite. Like they are saying that this work is not possible. So like if what I had thought that I'll be doing this thing, they have clearly mentioned that this is not possible, right? If you are trying to make it, we have tested, this is not working. So the time, this is, completely, one fool will try to do this, like this kind of statement I have seen in some of the papers.
Fine.
So what should we do in this?
No, so suppose, okay, so let's say that these research articles are opposite to each other, right?
Yeah,
now,
sir. Exactly.
now what we have to do, you have to look at the timeline, right? Which one is the latest one? Okay, so for example, if somebody is saying that 10 years before, okay, people were talking about that this is not possible to get this thing, but now something is going to be very much possible here, right? So if you are encountering this kind of opinions, okay, but you need to also look at some of the micro facts. Microfact means that are they using the same conditions, experimental condition, or same algorithms, for example, okay, or they are going to have some kind of a slightly different things, okay. Second thing is that out of these two, one will be wrong. Either things is possible or not, right? So it means that you need to find out which one is telling the truth, basically, right? So I would have not encountered such kind of a problem where people are saying that opposite to each other at the same conditions. Okay, some of the constraint might be there, but I mean, exact opposite is I have not seen it. But what I would say that if you follow the latest research going on, right? If somebody has said that if something is not possible, you need to look at the causes behind that. Okay, why this thing is not possible? Okay.
Okay, sir. So, sir, in such situation, like which one we should prefer, like the experiment-based papers or some simulation or mathematical-based papers? Like which one we should, give more weightage to make up our mind?
Certainly, okay. Certainly, in my personal opinion, you should give more weightage to the experimental things because you can visually see from your eyes, right? You are doing something, you are getting some results, okay? Simulation always considers some kind of idealistic condition, right? Okay. Simulation is where you can easily change some of the conditions and that is going to be directly affect the output. Okay. So personally, I always indicate that you have to trust experimental results more than your numerical results. Okay. This is my personal opinion. Yes.
Yeah. Okay. Thank you so much, sir.
Any others have the question? Supriya ma'am, please.
Yes, ma'am. Sir,
Yes, madam.
one thing I would like to clear from you is, sir, actually, if we are doing the experimental work based on some particular algorithm, and what will happen that for one of test.
Madam, I'm not able to hear you
Your
clearly.
voice is not audible, ma'am.
Now is it audible?
Yeah.
Hello. Okay.
Yes, audible.
Sir, yes, sir. Sir, actually, one paper is based on two algorithms which has been tested for one case study. And same case study, if we would like to means take as a case study for next two algorithms for comparative analysis. So each time the case study is same, so all parameters and all will be same. So whether it will be, and always it will come in plagiarism. So how we can deal with that?
I mean, I have not really understood your question. But the idea behind plagiarism is only based on 3 facts: falsification, as I mentioned, okay, reporting the data without doing an experiment. Third thing is that do not, if you are not providing any kind of a due credit to somebody, okay, these are 3 parameters. Now, if you are saying that you have chosen some experiment based on the 2 algorithms, okay, so basic idea is that you need to provide the proper citations during your work, okay. Um,
Okay, sir. Okay. Sir, but if it is same, if it's my paper and I would like to, so is it okay that I have to cite my paper again and again for different kinds of, for testing the different algorithms for
Yes,
same case study?
yes, Supriya. So, I as mentioned earlier, if you have transferred your copyright to any organizer, then this is no longer your paper. You do not have any authority over that work. Okay,
Okay.
that's why this is called copyright transfer. Okay,
Okay.
so even for using your own work, ideally you should take permission from that publication house.
Okay,
Okay,
sir.
but
Okay.
normally in most of the situation, most of the publication house, they are very lenient if you want to use your own work. Okay, so they don't make any kind of a concern.
Okay, sir. Okay, sir. Thank you, sir.
Any other questions, please? Okay. As such, no
Ma'am,
questions?
I wanted to ask one more question. Sorry, ma'am, I
Yes,
forgot to
please
ask
go
that.
ahead. Go ahead.
Uh, Sir, you have mentioned one more thing while defining the research problem. 2 points you have mentioned during the presentation, sir. Like, one is the need of the problem, and second one is the present status. So, which one we should give more weightage, like when we are deciding our research problem?
See,
Whether the need of the problem or the present status, like industry point of view and other things.
so need is that that why we are doing this problem. Okay, so for example, government is pushing it for going for a green energy, so we need a solar cell, correct? So that is the need. Now, characteristic is that what are others doing, so that how you can contribute, okay, something useful to the already existing knowledge. That is the meaning of current status. So this guy is doing this work, this guy is doing this thing, okay, what new you want to add in the existing solar cell problem. Okay, so there are 2 different things: why you are doing this problem, okay, and how you are doing this problem, why and how. Okay,
Okay. Okay. Thank you.
Okay. I hope all the queries, Deepak Sinha, it is clear at your side.
Yes, ma'am. Yes, ma'am. Sure.
Yes.
Yeah.
Any
Thank you so much, sir.
no such questions?
very
So
nice. Yeah.
really, definitely our design research problem is an essential step in the design process for creating any product or the framework that truly matters. The step 2 in the design thinking that is defined, and this term or terminology, the problem statement, defining the problem statement, that sir is nicely mapping these particular aspects with the design thinking steps for the formulation of the research statement and its the challenges. So I hope all the participants really enjoy this session in the manner. So now, thank you so much, sir. Behalf of Bharatiya Vidya Bhavan, Sardar Patel Institute of to Dr. Pradeep Dixit, sir. Thank you so much, sir.
Thank you, Dr. Sujata. It was really pleasure experience for me to interact with all the participants, and I hope that I have conveyed my thoughts with all of you. Thank you very much.
Yes, sir. Thank you so much.
Thank you, ma'am.
Yeah, the instructions to the participants. Now the session is concluded, but before that, request to all the participants to fill up the feedback form, which is already given in the chat box. In the throughout the day, the session is very much interactive. Many of the participants shown the interaction, But moreover, I would like to share the name of today's interactive participants or the active participants from throughout the 3 sessions is Deepak Sinha. So really it is a nice and interactive one. So please give the applause to the active participant Deepak Sinha.
Thank you so much. Thank you so much,
Yeah.
ma'am. Thank you so much.
So we will share the certificate in couple of days.
Sure, ma'am. Thank you so much.
Thank you all the participants to quietly listening the sessions and make the session interactive. We'll meet tomorrow at 9:30. Thank you.